All right, we're looking at 4.7 transformations of polynomial functions. So these listed here are the transformation functions that we've used before. Hopefully we know them all from Algebra 1. We have x minus h, where the h is contained within the parentheses, so you actually add a number or subtract a number right next to your variable term. That one shifts it left or right. We have, if we add something on the end, k, that moves him up or down. We have a reflection in the x-axis. That's the bottom one here. And then we also have this one that we don't use quite as much. If we put a negative right next to our x, that would be a reflection in the y-axis. Horizontal stretches and shrinks, we don't use those a whole lot, but they are sometimes useful. The ones that we're going to use much more often will be vertical shrinks, where you have an a value out front. And that does a vertical shrink or stretch by a. So let's look at number 40 real quick. Describe the transformation of f of x equals x cubed, represented by g of x equals x minus 3 cubed minus 1. That minus 3 moves it right 3, and the minus 1 moves it down 1. Now, we can use a graphing calculator, but I have this graph kind of in my head. The graph of x cubed, we have a dot at 0, 0, a dot at 1, 1, negative 1, negative 1, and it looks something like that. Oh, that's not very good. Let me see if I can draw it a little bit better. Graph something like that. This is f. And then if we draw it again, we're going to draw g this time. We move right 3 and down 1. So I'm just going to move all of my points with it. And there's my new graph. It doesn't look perfect. It should be just a perfect movement of the f, which would be the parent function of the cubic polynomials, but it's pretty close. If you have a graphing calculator, that'd be a great thing to type in. Just plain old x cubed, and then parenthesis x minus 3, or the quantity x minus 3 cubed, and then minus 1. On tests, on quizzes, you can expect at least one problem, something like this, where it asks you just to describe the transformation. Because we want to make sure that we know those left, right, up, down rules, and then also the vertical stretch and shrinks. For these, especially because it is a cubic, and we don't really, I don't preach the cubic parent function a whole lot, I'm okay with using a graphing calculator to graph these. Like whenever we're graphing earlier in this chapter, we want to have the general shape, the end behavior, and then some points on it as well. Number 41, let the graph G be a vertical stretch by 2, followed by a translation 3 up of the graph of f of x. Write a rule for G. So starting off, we just look at a rule for G of x, just using plain old f, not actually plugging in what f is. So to have a vertical stretch means to multiply by 2 out front, so we have 2 times f of x. And then we went 3 up, so we add 3 on the end. So this 2 goes right there, 3 right there. Now I can plug in the actual f. So I'm going to say g of x equals 2 times f of x, which is x to the 4th minus 2x squared, and then plus 3 on the end. Distributing out, I'll have 2x to the 4th minus 4x squared plus 3. And that's going to be g of x. And that's all we got to do there. Let's look at number 42. The function v of x equals x cubed represents the volume in cubic feet of a cube with edge length x. The function w of x equals v of 1/12 of x, or 1/12 x, represents the volume of the cubic feet when x is measured in inches. Volume in cubic feet when x is measured in inches. There we go. We should say in right there. The volume in cubic feet when x is measured in inches. write a rule for W, and then find and interpret W of 96. Alrighty. So right here we got that 1/12. That converts the inches into feet right away. So let's actually just look at W. We're going to take this 1/12 of x and we're going to plug it into that x up there, the v of x. So we're going to have 1/12 x all cubed. This will be the same thing as x cubed over 12 cubed. And I'm going to write out what is 12 cubed. I don't remember. 12 cubed is 1728. So this is x cubed over 1728. So W of x equals x cubed over 1728. All right, there is part of our answer. And remember, that function there allows us to input inches and get out cubic feet. Whereas this plain old v of x has you input feet and you get out cubic feet. Now I'm going to plug in W of 96. And I'm just going to type this in my calculator. 96 cubed, and then divided by 1728. That gives you 512. So a cube with side length 96 inches has volume 512 feet cubed. And there we have it. That's going to be our answer. Section 7, just to talk a little bit more about it. This is one that we normally don't hit on too hard. To be able to transform polynomial functions, you normally have to really be good at graphing them. So if you're struggling with section 7, try to look back at our graphing section. Which one was that? Let me find where he was. I think he was just section 1, wasn't it? Yep, right here. So all these different little sketches that we had, like example 5, maybe it would be beneficial to think about moving that graph left or right, or up or down, or stretching it or shrinking it, something like that. Those are good things to think about. All right, that is it for transforming polynomials. Let me see back on the title page, make sure I talked about everything I needed to. Yep. Make sure for sure that you know these yellow highlighted pieces. The blue ones are good to know if you want them, but I'm not going to test you over the blue highlighted pieces. It's just the yellow ones that we really want to know. All right, that's all.